Hi, welcome back to AT Math. Today, 12.5, adding and subtracting rational expressions. This is going to be a longer video, definitely 2 parts. Maybe give yourself a break as well if you need. Alright, let's begin. Remember 1/6 plus 3/6. Remember we're adding like fractions. The denominators are the same. So 1/6 plus 3/6 makes 4/6. 4/6 you can divide both by 2 and get 2/3. And 13/2a plus 3/2a, both being divided by 2a, so 13 plus 3 is 16 all over 2a. 16 and 2 can be divided by 2, giving me 8 over a. Plus, if you have 1/6 plus 2/5, we have to make the bottoms the same. To do this, 6 and 5, the least common multiple is 30. So I'm going to take 6 times 5, but I'm going to times the bottom by 5. You got to times the top by 5. Because with fraction, you can do that if you do it to the top and bottom. For this one here, to make the 5 into a 30, I times the bottom by 6, and also times the top by 6. Alright. Well, 1 times 5 is 5. 6 times 5 is 30. 2 times 6 is 12. 5 times 6 is 30. 5 plus 12 is 17. Now, adding rational expressions with like denominators. If a, b, c represent polynomials and c does not equal 0, then a over c plus b over c equals a plus b over c. Basically the same thing I just said. Here, you're dividing 3b and 5b, and you're dividing them by b squared for both, so you're just going to add them together. So 3b plus 5b is going to be 8b all over b squared. However, they then divided b out. So the 1b and 2b fight it out. The 1b loses. This 2b becomes 1b. Why? Because you minus a b from both, top and bottom. So it's 8 over b. And another, x squared minus 8x. We can pull out an x here, which you'll see in a second. Wait a minute, they do it a little differently, excuse me. X squared minus 8x plus x squared minus 8x plus 2x plus 8, they're all being divided by x minus 4, so we're going to add them all together. So you're going to say, okay, x squared is there. Negative 8x plus 2x is going to be negative 6x, because negative 8 plus 2 is going to be positive 6, and plus 8 by itself. So all this becomes this. And then I'll still over x minus 4. This then splits into x minus 2 and x minus 4. The x minus 4 on top and bottom cancel, and the answer is x minus 2. Now if they wanted exceptions as well, which they didn't ask for, but if they did, you would say x minus 2 and x does not equal 4. You don't have to put that, but if they asked for it, you would. Remember from a couple lessons ago. And 2m plus 4 over m squared minus 9 plus 2 over m squared minus 9, they're both being divided by m squared minus 9, so add these together. 2m remains the same, 4 plus 2 is 6. Divided 2 out of the top to get 2 times m plus 3, and this splits into m minus 3, m plus 3. These cancel, leaving 2 over m minus 3. Again, if you were to include exceptions, you would say m does not equal 3 or negative 3, but I'll stop saying that because they're not asking for it here. You try. Go ahead. Let's see how you did. N plus 3n is 4n, divided by 2n, divide both by 2n, answer is 2. You try number 2, 3y squared over y plus 1 plus 3y over the y plus 1. Go ahead this time. Let's see how you did. When I combine them, I divided 3y out of the top, leaving y plus 1 over y plus 1, cancel, cancel, leaving 3y. Now, 3m minus 6 over m squared plus m minus 6 minus negative m plus 2 over m squared plus m minus 6. Notice how I have a minus and not an add. What you can do is you can first take this negative and switch both top signs, getting rid of the negative and turning it into a positive. It's basically what we're going to do is, okay, we're going to say turn this into a positive, means we switch all the signs. That's the easiest way for me. So then you're going to say, okay, I have 3m plus a positive m, it's going to make 4m. Negative 6 plus a negative 2 is going to make negative 8. From there, you go ahead and pull a 4 out, like you did, m minus 2. And m squared plus m minus 6 is going to be m plus 3, and m minus 2, cancel, cancel, 4 over m plus 3. You try. Same idea, go ahead. Let's see how you did. Hopefully the negatives switch both numbers here, so instead of a positive 2a, it's a negative 2a, instead of negative 4, positive 4 is seen here. Combine these to become 3a plus 6 over a squared minus 4, pull the 3 out, split a squared minus 4 into a minus 2a plus 2, cancel, cancel, 3 over a minus 2. Wait a minute, I made a small mistake. If that's the case, this should be a minus 2. Whoopsie. Alright, try again. 2b plus 14 minus negative 2b plus 2. Remember, we're going to be switching these signs. Go ahead. Notice here that when we switch the signs, it's going to be positive 2b and negative 2. So I basically just combine them, saying 2b plus 2b is 4b, 14 plus negative 2 is 12. Pull a 4 out here, split these apart. We can't break this down, so we're going to keep this one as is. So basically, that's as far as we could go. As with fractions, rational expressions must have a common denominator before they can be added or subtracted. If they do not have a common denominator, you can use the least common multiple, or LCM, of the denominators to find one. To find the LCM, write the prime factorization of both expressions. Use each factor the greatest number of times it appears in either expression. Now, this seems like a lot of work, but I like how the book does it, actually, and I'm not often to compliment the book, but this time I'm going to say they did a good job, because they took 6x squared and they listed each part. They said 2, 3, and 2 x's. 8x, they have 2, 2, 2, and an x. Now the least common multiple is combine the best of each one. So here, 1, 2, 3 2's, we'll take the 3 2's. 1, 3, no 3, we'll take the 3. 2 x's versus 1 x, we'll take 2 x's. Add them up, combine them in other words. 2 times 2 times 2 times 3 is 24, and x times x is x squared. Least common multiple. Here, 5x plus 15. Pull the 5 out and make x plus 3. X squared minus 9, you get x plus 3, x minus 3. So you have a 5 and no 5, take the 5. X plus 3 and no x plus 3, take x plus 3. Nothing and x minus 3, take x minus 3 and combine it this way. And that's how you do it. Now take this, 24a cubed and 4a. Find the least common denominator, least common multiple, whatever. So go ahead this time, you take a look here. 24a cubed, 2 times 2 times 2 times 3, and a. And 4a is 2 times 2 times a. So 3 2's are better than 2 2's, 1 3 is better than no 3, and 3 a's are better than 1a. So you have 24a cubed. Now, 2d squared plus 10d plus 12, and d squared plus 7d plus 12. You go ahead and break it down like so. First I'm going to pull a 2 out of this monster, and then go ahead and split this up into d plus 3 and d plus 2. And this guy, what they did was they just split into d plus 3 and d plus 4. They left a gap because there's no d plus 2. Therefore, 2 and nothing makes a 2, d plus 3 and d plus 3, well, we'll just take d plus 3. D plus 2 and nothing, we'll take d plus 2. Nothing, d plus 4, we'll take d plus 4. You can keep it in this form, or we roll it back up into a giant, well, I think it would be a quadnomial. It's up to you. I'll take this if you like instead. In other words, you don't have to put it all back together. Now you try 5f squared h and 15f h squared. Go ahead this time. See how you did. 5f squared h, 5 times f times f times h, 15f h squared, 3 times 5 times f times h. There's 3. We'll take a 5. We'll take 2 f's. We'll take 2 h's. And that is your least common multiple. You try again. X squared minus 4x minus 12 and x minus 6 and x plus 5. Hint, break this down first. Alright, go ahead. Let's see how you did. First we break it down. This becomes x minus 6, x plus 5. And this was already x minus 6, x plus 2. Therefore you already have an x minus 6. X minus 6. You have an x plus 2 and an x plus 5. Those are all least common multiple. Remember, you only have to take one of these, one of these, one of these. And there you are. Least common multiple of the denominators of fractions or rational expressions is also called the least common denominator, or LCD. I just said that. You can use the same method to add or subtract rational expressions. Identify the LCD, multiply each expression by an appropriate form of 1 so that the term has an LCD as its denominator. Write each expression using the LCD. Add or subtract the numerators, combining the terms as needed. Factor, simplify as needed. Take this example. 1/6 plus 2/5, we already talked about this, change them into 30s. You know, you get 5 over 30 plus 12 over 30, 17 over 30. No step 5 or 6 needed, but a little more complicated one. Adding and subtracting with unlike denominators. Again, 3x over 6x squared plus 2x over 4x. We have to make 6x squared and 4x into least common multiple, least common denominator. So, what we're going to do is line them up again. 6x squared, 2, 3xx, 4x, 2, 2x. Line them up, 2, 2, 3xx. Combine them, 12x squared. So we have to make both into 12x squared. To turn this into 12x squared, we times the top and bottom by 2. This one you times by 3x, as shown. So now both 12x squared. So you have 12x plus 6x squared, combine them. Now personally I'd put the 6x squared first, but you don't have to, I guess. They're going to pull out a 6. They're pulling out a 6 in this guy. These cancel, leaving 2 plus x over 2x, although again I would have x plus 2 over 2x. It's my preference, and really it's the way it should be. This time you need to find the least common denominator, so go ahead, m minus 3 and negative 5 over 3 minus m. The denominators are opposite binomials. The least common denominator can either be m minus 3 or 3 minus m, so you either have to make this into this or this into this. It doesn't make a difference. Well, the first thing they're doing is times them by negative 1s. Now to do that, you can go ahead and times by negative 1, you're basically switching. Now, again, if you're having a little trouble with that, remember this can also be written as negative m plus 3, because it's a negative m value and positive 3. And if you negative 1, you switch the signs as follows. M minus 3. Now both are m minus 3 now at this point, and you can say 1 minus negative 5. There is one more thing you could have done if you wanted. Now you could have instead said, well, there's a negative already here, so I'll just use this negative, change it to a positive, and switch both of these signs. Now you might say, wait a minute, you're switching the bottom and not the top. As long as you're switching a set completely, whether it's top or bottom, it's the same thing. So you could do that and say, okay, now I have my m minus 3 over 5, and look what happens. 1 plus 5 is 6, just like you have down here. So there's more than one way to accomplish it. If you need help with that, just ask me in class. I'll be happy to give you a few examples. So we'll go with that. Either way you try. 4 over 3d minus 2d over 2d cubed. First, remember, find the least common multiple. Go ahead. Let's see how you did. So 3d minus 2d cubed, 2d cubed, and 3d. 2d cubed is 2 and d. 3d is 3 and d. 2 and nothing makes 2. Nothing and 3 makes 3. 3d's versus 1d. I'll take the 3d's. 2 times 3 is 6. D times d is d cubed. Have to make them all into 6d cubed. To get there, I'm going to take this times 2d squared, and the top times 2d squared. The bottom here, I'm going to take times 3, and the top times 3. These are just extras I didn't need. So basically when you multiply it across, you get 8d squared over 6d cubed, and here I have 6d cubed over 6d. Since I can't subtract them, actually they stay together. 8d squared minus 6d. I'm going to pull out what I can, which is 2d on top, and pull out 2d in the bottom. I think you know where this is headed. Cancel, cancel. 4d minus 3 over 3d squared. You try number 2. 8 squared plus 4a over 8 squared plus 2a minus 8 plus 8 over 8a minus 2. Go ahead this time. Take a look here. I want to combine these two. Notice how 8 squared plus 2a minus 8 becomes 8 minus 2 and 8 plus 4, and this already is 8 minus 2. So I just have to time the tops and bottom here by 8 plus 4. You know what? I did something different instead. I actually went ahead and just combined out the 8 plus 4, which actually is a better idea. You could times them both by 8 plus 4, but instead I made my life easier by just saying, instead of doing all that, let's just cancel out the a minus 4s. Good thinking. So a over a minus 2 plus 8 over a minus 2. A plus 8 is going to be a plus 8 over a minus 2. If I would have times them both by a plus 4, I would eventually have got all the way back here, but it would have taken me longer. So if you can pre-divide, always a good idea.